everyone. Thanks for coming to my talk. I'm someone from StackHPC. Today I'm going to talk about our experience of how we automated in-place Ubuntu upgrade on our customers' open infra with Kayobe. I want to go through about myself a bit. So I'm a cloud engineer. I graduated University of Bristol in UK as a computer science graduate. I served my country as a software developer for 18 months, and then I joined StackHPC November last year. So since then, I became an operator using Openstack. I contributed to CloudKitty and also Cola. Recently, trying to contribute to Blazor as well. Let's go through about my employer a bit as well. So StackHPC was formed in 2016, UK, Bristol. Now we have about 30 people around Europe, UK, Poland, and France. We expertise HPC, OpenStack, and open infrastructure. We do the OpenStack development and operations. We are proud of our heavily involved upstream community work. If you can see the figure on the right side, we are top 10 of upstream contribution, or even top 5 sometimes. We're also proud of our open way of working. We do the upstream development of open infra for research purpose, and we're interested in HPC technologies in cloud native context. We do the consultancies to organizations that needs HPC cloud environments. We also do the training and supportings for that. And we do the active engagement to the scientific OpenStack community. Let's actually go through about today's subject. So why we wanted to do this. So we wanted to upgrade our client system to OpenStack, from OpenStack Yoga to OpenStack Antelope for improved security and newer features. But from OpenStack Zed onwards, Ubuntu 20.04 support was finished, and most of our Ubuntu using clients are still using Ubuntu 20.04 release. So we had to upgrade all the hosts of all our clients to Ubuntu 22.04, which is quite a large number. So our targets were simple. Because most of the hosts of client system are production ones, so we have to minimize the downtimes, ideally no downtimes. Fast, simple, and reliable process for operators for consistency. And the process itself should be easy to automate. So before we go through how we actually automated this, I think I need to explain a bit how we deploy the system, the client system. So we utilize Cola Ansible and Kayobe. In case you are not familiar with Cola Ansible and Kayobe, so Cola Ansible is a helpful tool to allow deploying containerized control plane with Cola images. We can deploy each Cola services independently, and it's easy to configure each services using only INI files. As the name suggests, Ansible is provided for that, and it gives easy solutions for operators. But Cola Ansible largely assumes that hosts are already configured, deployed, and running Docker. And Cola Ansible has limitation on configuring hosts. So that's why we use Kayobe as well. Kayobe is OpenStack project named after Kayobe, which means Cola on Bifrost. This OpenStack project adds some missing features from Cola Ansible, such as bare metal control plane deployment using Bifrost and Cola Ansible inventory management. But today we're going to focus on the feature of configuring the hosts and its OS. The way how Kayobe knows how to configure the host is that all the configurations are defined with Kayobe config. This is good because it can be easily version controlled using, for example, Git. And Kayobe also provides OpenStack-like CLI, which is friendly for our operators, and also it gives some it also gives some Ansible playbooks. So here's how we usually deploy our customer system. Our operator connects to Ansible control host and running Kayobe commands. Kayobe first deploys the seed host and configures the seed host to use Bifrost and Pulp. Pulp here is just a custom repository, package repository we use to minimize the impact of untested packages. Like unexpected updating can be unexpected updates from certain package can break the system. So we wanted to prevent that, so that's why we use Pulp. And then Kayobe also deploys the control plane, controller hosts, hypervisor hosts, and storage hosts. We use Ceph as our storage service, so Kayobe deploys Ceph, and Fluentd is for our centralized logging using OpenSearch. Then Kola Ansible comes into play, deploying all the Kola services we need, such as Nova, Neutron, Keystone, Glance, for example, and also on the hypervisor hosts as well. And that's all done. After that, end users can finally try working on their project using the VMs. So why in-place upgrade if you can provision the host or re-provision the host using Bifrost? Yeah, traditionally we did that. We deprovisioned the host with old OS and then re-provisioned with newer one. But it takes a lot of time for each host because now we need to set up the OS, then we need to configure the hosts again, then we need to deploy the Kola services again on that. And our customer system can have several hundred hosts in total. So that will be very painful time for our operators. So in-place upgrade has benefits of giving much simpler and faster approaches for each action, because we are only upgrading OS. The host configurations used by Kayobe and Kola services that were deployed are untouched. And additionally, because we're not resetting the host, we can retain all the history and logs on that machine. This is the overview of the upgrading process. So 3-phase: pre-upgrade, upgrade, and post-upgrade. For first part, we evacuate all the workloads from the hosts. If the hosts are hypervisors, then we live migrate VMs to the ones that are not getting upgraded yet. If it's storage nodes, then we set the maintenance mode for Ceph. And then we update all current hosts package to latest for a smooth transition on the upgrade phase. So next upgrade phase, we upgrade hosts using do release upgrade, Canonical's official solution. And then we reboot to newer release. After upgrade for each host are finished, then we do the update old host configurations. So some configurations can be now old because they might be based on the old OS information, so we need to update that. Then we restore the workloads to host back to where it belongs. So live migrate again the VMs if it's hypervisor, and if it's storage, we unset the maintenance mode. Then after all that, after we think the upgrades are finished, we validate the system to ensure that we are all happy with the status of the system. So these red parts are automated with scripts. The evacuation of workload and restoring it was not included because they were all little different between customers. So what does the script actually do? So it's just the Ansible playbook nested with shell script. Shell script just ensures that the operator session has the environment variable that is needed for the action. Then if it checks all out, then it calls the Ansible playbook. So Ansible playbook checks the host is actually running Ubuntu 20.04 to prevent accidentally running this playbook on irrelevant host like host with Rocket Linux. Then the playbook ensures the host has latest packages and kernels. So this is where we update the packages to latest before upgrading. And we need the playbook reboots the host if necessary. This can happen if the updating process updated the kernel, and then after the reboot, we start upgrading the OS using do release upgrade. Then after that is done, host is getting rebooted to Ubuntu 22.04. Then we update the old configuration. So that looks simple, and I wish that is the end of the story, but what went wrong? We tested the upgrade process using our testing environment, and we found some parts that can go wrong. Let's go through one by one. So using custom repositories, as I said, we use Pulp as our custom version controlled package repositories to avoid untested packages breaking the system. But Kayobe removes default repositories at etc/app_sources.list to ensure that our custom repositories under etc/app_sources.list.d directory is used. However, do release upgrade only checks etc/app_sources.list, and that file is now empty. So what it does is it decides to use the default Ubuntu upstream package repositories as an upgrade source, and that ruins our versioning. So we had to make another Ansible playbook that defines the custom repositories again on sources.list just for the period of upgrading. VM live migration failure. This only happens with certain AMD CPU using hosts. So this happened between the VM. This happened when we were trying to live migrate VMs between Ubuntu 20.04 hosts to Ubuntu 22.04 hosts. So for Ubuntu 22.04, CPU flag X saves were disabled for AMD Zen and Zen 2 CPUs due to instruction malfunction. But the VMs that were originally created with 20.04 hosts, now it requires the X saves features, but with the 22.04 hosts now, they don't have that feature anymore, so the live migration fails. We had to, unfortunately, cold migrate those VMs. We had to coordinate with customers because we thought it's safer to do cold migration with some coordination with customers rather than trying to change some CPU feature requirements for VMs that is in production, or adding the CPU capabilities to hypervisors that is also in production environment. Python versioning problem. So Python version gets upgraded as well from 3.8 to 3.10 during the Ubuntu upgrade. However, the Python virtual environment that is used, the Python version of it stays at 3.8. So this broke all host management using Ansible playbooks because it uses Kayobe's Python virtual environment. Well, the solution was quite simple. Using Kayobe to remove and recreate the Python virtual environment to ensure that Python inside the virtual environment is 3.10. Now you might ask, if Kayobe doesn't work, how can you do that? So there's an option in Ansible choosing which Ansible Python interpreter to use. So we decided to use the interpreter from the local host. In this case, in our case, it will be Ansible control host rather than the target host. So that allows each tasks from playbook can be run, even though there is no Kayobe virtual environment for target hosts. Losing connection to host. So this was quite critical one. We found that during the upgrade process by do release upgrade, it can uninstall the package related to network. It was if up down in our case. Rebooting the host without knowing that means total loss of this host if you don't have any BMC access. So to prevent that, we had to ensure that Kayobe configures network configuration before the reboot, again to ensure that the network interfaces and routings are not lost before we boot the system. This was quite easy because our network configurations were all defined in Kayobe config already. Network interface name change. This is not that critical. The one like the one before. After rebooting the host with Ubuntu 22.04, the name of the interface name can change sometimes. So like ENS1 goes to ENS1 MP0, or it can go total crazy and do the ENS2 F1 to ENS EMP161 SOF1 MP1. So yeah, the Kayobe that is configuring some part of networking could fail because the name of the interfaces are defined in Kayobe config and it expects that to be there, but now it's not there. Names are changed. We had to redefine some network interface name manually because we wanted to automate that, but we couldn't find the whole pattern of how the name changes. If you know it, please let us know. We're open to suggestion. So this is the final version of upgrade script. You can see some parts were added, like for custom packages, we explicitly set those, and for Python virtual environments, we recreate them to ensure we use Python 3.10 and reconfigure network interface before reboot to ensure we don't lose the host after reboot. It is a good idea to validate the system with this such big job. So we tested OpenStack with Tempest, OpenStack functionality, I mean, using OpenStack API. And then we tested like migrating and creating the VMs manually just in case if we find something odd. And we checked OVN status, and we also checked system alerts and logs to see if there are any unexpected logs or anomalies. So in conclusion, we are happy with our result with Ubuntu automation because it gave faster, simpler solutions for our operators upgrading a large number of hosts. And thanks to Kayobe and Kayobe config, the configurations between the hosts are consistent. And for the future work, like upgrading the Ubuntu to the recent release 24.4, we will be able to reuse this automation with just minor tweaking. So yeah, we highly recommend applying some automation to Ubuntu upgrade. Well, not exactly like this. Well, it depends on your system, but yeah, I hope this can be some inspiration. And thank you very much. The left one is LinkedIn for StackHPC, and right one is LinkedIn for myself. So if you have any interest or questions, please feel free to contact us. And if you have any questions related to this, yeah, please ask some questions. Thank you. Thanks for coming.